Okay, so let's look at 3a. Describe each graph below. Let's just look at its equation. So if we start with the first one, we've got y equals x squared. And how is that moved? So if you think about it, it's moved from over here. It's moved 2 across. All right, so I could kind of think of it as 2 across means x minus 2. 2 to the right means x minus 2. So now what I've got is x minus 2 all squared. Okay, and we just need to check that. So when I expand that out, do I get a y-intercept of 4? Yes, I do. So our equation for that one is just y equals x minus 2 all squared. Sorry for the messy writing. All right, so then if I look at the next one, whoops, that's what I need. So if I look at the b, so we know it's based on y equals 1 on x. And again, you can think of it, look, it's moved across 2. So you can think of it as f of x minus 2 to the right and put x minus 2 in. Or, you already know, okay, the vertical asymptote is at 2. So I need an x minus 2 there. And then think about how else things can change. First of all, it hasn't gone up or down, so I don't need plus something or minus something. But this number here could be different if the dilation. So we can check. So we sub in a point, for example, 3, x equals 3, y equals 1. If I do that, 3 minus 2 is 1. So k is equal to 1. So that's all good. So it is y equals 1 on x minus 2. That is our function there, 1 on x minus 2. All right, so if I look at the next one, so we've got for the next one, wait till I got a pen, there we go. So for C, we know it's an exponential, so I'm going to base it on some dilation of some base to the power of x. Now I don't want it really to be in a plus 1 or a minus 1 here, because that puts my asymptote up 1 or down 1 if I or if I did it by plus b or minus b. So we know we don't need that because our asymptote is still 0, y equals 0. Okay, so that hasn't moved. So let's just deal with this. So a couple of things we could put, we've got the y-intercept is 3, so that means when I put x equals 0 in, of course, so if I use 0, 3 here, let's put that in. So we've got 3 is equal to k times a to the 0, and a to the 0 is 1, so k times 1 is k. So now we know that k is 3. So far we've got 3a to the x there. The other point we've got is this point here, which is negative 1, 1, negative 1, 1. If I use that, 1 is my y, and negative 1, there we go. That, and if you think about that, that's the same as 3 on a. So if I multiply 1 by a, then I have a equals 3. So put that together in here, and you've got y equals 3a to the power of 3. So y equals 3a to the power of 3. All right, so the next one, whoops, get rid of that. For those with OCD, we'll get rid of that. All right, so the next one we can see that it's just a circle. You told me, I think before, some people told me that if I have a look, I can see, now I've just made it so you can't see, I can see the radius. So it's gone from negative 2 over to a 0. So that's a radius of 2. So I know it's got a radius of 2. So I know it's going to be equal to 2 squared, which is 4. And I know the center is across at minus 2 minus 1. So straight away we know it's x plus 2 squared and y plus 1 squared equals 4. So that's our equation for that circle. Never write it like this. But just to fit it on there. Okay, and then the next one. Okay, so now we have, what do we have? Oh, we have an exponential again. So we're basing it on our normal exponential there. Whoops. But we do know for this exponential that, firstly, it's moved across to the right 2. So again, we know that's a minus 2 on the bottom, or f of x minus 2 is what we've just done there. So that's our first thing. This time it's also moved up. Oops, where's my pen? Down, even, down to, so it's now at -1, so y equals -1 is that asymptote. So it's gone from 0 to -1, so we know we have to take it down. So in other words, we're taking the function and subtracting 1. So we can just do that. Okay, subtract 1, done. Okay, and we just need to check its dilation or any dilation. So this, oops, lost my pen. Nope, still have a pen, just can't write. Okay, that could be K here, so we could change its dilation. So what point haven't we tried? Let's have a look at this point. This point here is across at, is that across at 3? 3, 2? Nope, I think it's across at 2 and it's got a height of 3. Oh, it's very confusing. All right, let's make that point. Or is it a height of 2? Okay, now I can't even see. Let's have a look there. What have we got? No, the x value is 2. I'm pretty sure that's saying the x value is 2. Oh, that's the x-axis that I can just not see. Okay, so that's the x-axis along that line there. So it's yeah, okay. So it's at 3, 0, that point there. I just couldn't see it with my blind eyes. So let's go. We know the point 0, the x-intercept is 3. So, oh, and then I've written it wrong. So 3, 0, cross, no, yes. So 3, 0 is what I'm subbing in. All right, let's try again. So 0 equals k on 3 minus 2 and then minus 1. So if you think about that, 3 minus 2 is 1, minus 1 has to be 0. So yes, k has to be 1 because that would give us 1. Minus 1 is 0. So now I know, and I can write it here, y equals just 1 on, they're keeping it simple, x minus 2, and then subtract 1. So it's moved across 2 to the right and down 1. So nothing too hard. I'm making it more difficult than it needs to be by looking at those dilations. All right. Last one. Again, last one is parabola like the first one. So it's based on y equals x squared. But you can see that the vertex, so it's moved, it's moved across 2 to the right. So f of x minus 2 again, they like that one. So if I move it 2 to the right first, I get that. But it's also moved down 1. So we're also going to minus 1 or take that new one and minus 1. Okay, so we've got something nice and simple. Now I could just check, of course, if there's any dilation, but I assume there's not going to be because there hasn't been for these ones. So is the y-intercept 3? Well, if you expand this, you get an x squared and minus 4x plus a 4 and then minus 1. So yes, we do get, when x is 0, we do get a 3. So this is the simple curve that. And you can also just write it straight away as that because you know the vertex is 2 minus 1. This is in vertex form. Every so often, if there were harder graphs, we would need a k out the front and check another point to see if there's a dilation as well. But in these questions, except for this one, there doesn't seem to be.